All right. So for this video, we're gonna be going over comments and whatever else we fucking go over. I don't know. Honestly, going over comments is kind of pointless. Like a comment is a programmer readable note that is directly into the source code. Basically, comments aren't read by the compiler and are just there for humans to look at. Okay. So it doesn't actually. It's not actual code. It's just like basically just text that we can read to be able to explain things. Yeah, it's stupid. Authors note in this tutorial series our example falls into one of the following categories: full programs. Those are the main function. There's ready to be compiled snippets, small pieces of code, such as statements above. We use this to demonstrate specific concepts in a concise manner. Yeah, multi-line comments. You just use this and this, so you just encase it within a forward slash and a asterisk. So pretty simple. Multi-line comment styles cannot be nested. Okay, who cares? Doing multi-line comments side other multi-line comments, wrapping single-line comments side of multi-line comments. Okay, like who's gonna do that? Please tell me who is gonna do that. I really want to know. Like, heck, typically comments should be used for three things. First, for a given library, program, or function, comments are best used to describe what the library, program, or function does. These are typically placed at the top of the file or library or immediately preceding the function, for example. All these comments gives the reader a good idea for what the library, program, or function is trying to accomplish. Yeah, I'm not. Okay. Jesus Christ, bro. Finally, comments. Okay, yeah, it's basically comments are literally just like I said, they're just fucking things that aren't actually recognized as code. Okay. If you put two forward slashes, it just cancels out anything put after it in that line. Okay. So if you want to clarify what things are, then you do that. But I don't know why it's like trying to give us examples of it. Okay, best practice. Comment your code liberally and write your comments as if speaking to someone who has no idea what the code does. Don't assume you remember why you made specific choices. Commenting out code. Converting one or more lines of code to a comment is called commenting out your code. This provides a convenient way to temporarily exclude parts of your code from being included in your compiled program. To comment out a single line of code, simply use the / style comment to turn a line of code into a comment temporarily. Okay, there are quite a few reasons you might want to do this. You're working on a new piece of code. Okay, there's no reason. Look at this. Basically, when you're like, when say you're debugging or something, right? And you want to see if what is causing the problem, so you can like comment out some code, be like, oh, this thing's not working. Let me go and comment out this other thing to see if it's this that's causing the problem, stuff like that, right? Or if you just want to comment something out and try something different, but still leave the code there if you want to access it at a later point, right? All right, let's go to the next one. That was fucking wow. What a shit fucking module, bro. Who gives a fuck about some goddamn comments? Like, be honest. My bad. In lesson 1.1, statements in the structure of a program, you learn the majority of instructions in a program are statements, and that functions are a group of statements that execute sequentially. The statements inside the function perform actions that hopefully generate whatever result the program was designed to produce. But how do programs actually produce results? They do so by manipulating, reading, changing, and writing data. In computing, data is any information that can be moved, processed, or stored by a computer. Programs are collections of instructions that manipulate data to produce the desired result. Computer programs, both in source code format and compiled, are technically data too, so they can be moved, processed, and stored. However, in the context of a computer program, typically use the term code to mean the program itself, and data to mean the information that the program works with to produce a result. A program can acquire data to work with in many ways, from a file or database over a network, from the user providing input or a keyboard, or from the programmer putting data directly into the source code of the program itself. In the Hello World program from the aforementioned lesson, the text Hello World was inserted directly into the source code of the program, providing data for the program to use. The program then manipulates this data by sending it to the monitor to be displayed. A single piece of data is called a value. Common examples of values include a, numbers 5, and text hello. Sure. Yeah, so it's just a value of a variable. Is all the value is. Single piece of data is called a value, yeah. The random access memory. The main memory in a computer is called random access memory, often called RAM for short. When we run a program, the operating system loads the program into RAM. Any data that is hard coded into the program itself, for example, text just hello world, is loaded at this point. The operating system also reserves some additional RAM for the program to use while it is running. Common uses for this memory are to store values entered by the user, to store data read from a file or network, or to store values calculated while the program is running. For example, the sum of two values, thing to use again later. Think of RAM as a series of numbered boxes that can be used to store data while the program is running. Some older programming languages like AppleSoft Basic, you could directly access these boxes. For example, you could write a statement to go get the value stored in mailbox number 7532. Respect. Objects and variables. In C++, direct memory access is discouraged, which is DMA. We access memory indirectly through an object. An object is a region of storage, usually memory that can store a value, and has other associated properties that we'll cover in future lessons. How the compiler and operating system work to assign memory to objects is beyond the scope of this lesson, but the key point here is that rather than say go get the value stored in the mailbox number 7532, we can say go get the value stored by this object. Let the compiler figure out where and how to retrieve the value. This means we can focus on using objects to store and retrieve values, and not have to worry about where in memory those objects are actually being placed. Although objects in C++ can be unnamed anonymous, more often we name our objects using an identifier. An object with a name is called a variable. Key insight. An object is used to store a value in memory. A variable is an object that is a memory or name identifier. Naming our objects let us refer to them again later in the program. Nomenclature. In general programming, the term, let me just show you what this looks like. This is, this. Sorry, I was learning the Windows API. Let's open this instead. Okay. Let's just call this. Alright, so a value and a variable is, let me include a string real quick. Alright, so a value would just be like 13, right? So we have 13. That would be just some random value. Okay, so it's anonymous. It's an anonymous value. The integer 13. But a variable would be like setting value equals 13. Right? But see how that doesn't work? It's because identifier value is undefined, so we have to give it a definition. So we want this to be an integer, which integers are just numbers, right? Which they're just whole numbers. So if we set values equal to 13, and then we can print it out. Let's just print a value, and then let's run debug mode. The decryption that value is 13. True that. All right, but yeah, so that's a anonymous value, and this is a variable with the value 13 stored inside of it. Okay. All right. Although objects in C++ can be unnamed, okay, variable and instantiation. Okay, whatever. In order to create a variable, we can use a special kind of declaration statement called a definition. We'll clarify the difference between a declaration and definition later. That's what we looked at just now. The definition of the variable. So here's an example of defining a variable named x. Integer x. So this means x is of the type integer. At compile time, when the compiler sees this statement, it makes a note to itself that we are defining a variable, giving it a name x, and that it has a data type int. More on data types in a moment. From that point forward, with some limitations that we'll talk about in a future lesson, whenever the compiler sees identifier x, it will know that we're referencing this variable. When the program is run, called runtime, the variable will be instantiated. Instantiation is a fancy word that means the object will be created and assigned a memory address. Variables must be initiated or instant. Bro, I'm searching this word up right now. I go fuck. Google Translate. Let's see how they type this fucking word. Instantiation. Oh my fucking god. Bro, what? Instantiation. Okay, instantiation. Program is called run. The variable will be instantiated. Instantiation is a fancy word that means the object will be created and assigned a memory address. Variables must be instantiated before they can be used to store values. For the sake of the example, say that variable x is instantiated at memory location 140. Whenever the program uses variable x, it will access the memory and or value memory location 140. An instantiated object is sometimes called an instance. Data type. So far, we've covered the objects are regions of storage that can store a data value. How exactly data is stored is a topic of a future lesson. A data type, more commonly just called a type, determines what kind of value, for example, a number, letter, text, etc., object will store. In the above example, our variable x was given type int, which means variable x will store an integer value. An integer is a number that can be written without a fractional component, such as 4, 27, 0, -2, or -12. For short, we can say that x is an integer variable. In C++, the type of an object must be known at compile time when the program is compiled, and that type cannot be changed without recompiling the program. This means an integer variable can only hold integer type values. If you want to store some other kind of value, you use a different type. Key insight: the data type of an object must be known at compile time in order to instantiate it. Okay, respect. So yeah, it basically just always assign a data type to an object whenever you create it, okay? Or well, object as in variable. Okay. Integers are just one of many types that C++ supports out of the box. For illustrative purposes, here's another example of defining a variable using data type. Double. Double width. Define a variable named width or of type double. C++ also allows you to create your own custom types, something we'll do a lot in future lessons, and it's part of what makes C++ powerful. These introductory chapters will stick with integer variables because they are conceptually simple, but we'll explore many of the other types C++ has to offer, including double soon. Defining multiple variables. It's possible to define multiple variables of the same type in a single statement by separating the names of the comma. Following two symbols of code are effectively the same. Int a, int b is the same as int a, b. When defining multiple variables this way, there are two common mistakes that new programmers tend to make. When you're serious, the compiler will catch these and try to fix them for you, or ask you to fix them. The first mistake is giving each variable a type when defining variables in sequence. The second mistake is to try to define variables of different types in the same statement, which is not allowed. Variables of different types and must be defined in separate statements. Yeah. Easy to read. Okay, best practice. Although the language allows you to do so, avoid defining multiple variables of the same type in a single statement. Instead, define each variable in a separate statement on its own line and use a single line comment to document what it is used for. In C++, we use objects to access memory. A named object is called a variable. Variables have an identifier, a type, and a value. Some other attributes that aren't relevant here. A variable's type is used to determine the value in memory should be interpreted. The next lesson we'll look at how to give values to our variables, how to actually use them. What is data? Oh fuck. Okay. We just saw data is something that can be moved or processed or some other shit. Or stored by computer. Okay. What is a value? A value is, what was it? A fucking object that is assigned to a variable or isn't assigned to anything. What do you mean it's a value, bro? The value is okay. Yeah, I know that obviously. Oh, it's or instance of some other useful concept that can be represented as data. Oh, okay. Yeah, value isn't an object, I don't think. I think objects are just variables. Or objects are anything that can be assigned a value, pretty sure, and can be defined by a type. What is the region of storage? Usually memory that can store a value. Yeah. What is a variable? A variable is an object that can store a value and has to be defined by a type. Variable is an object that has a name. Oh. Okay, well, yeah, that's pretty fucking obvious. Sorry, some of these are just so obvious that like I don't even think about saying them, but it's just what it is. What is an identifier? Identifier is the type of an object, right? Identifier is a name that a variable is accessed by. Or am I retarded? Okay, so value would be the identifier of 13. Because that's what it's being accessed by. Yeah. What is a data type used for? To define the type of the fucking variable. Data type determines what kind of value the object will store. Well, yeah, data types can be used for like other things also. Like these okay, variables aren't the only objects in C++. There's many, many more. Okay. Question number 7. What is an integer? A fucking number that doesn't have a fraction. Integer that can be written without a fraction component. Okay, respect. How long has it been on for? 15 minutes. Variable assignment initialization. Oh my Jesus Christ, bro. Okay, I'm gonna leave this for tomorrow.